question number 4, solve each equation. These are exponential equations. So there's a couple of ways that we've learned how to do these now. One of the ways that we've learned to solve exponential equations is if this log base, or if this exponential base, has something in common with our constant over there, we change it into common bases. But there is no common base between 90 and 5. Only bases for 5 would be 5 and 25 and 125. So we'll go to our second strategy that we use, and that is to undo exponents with logarithms. So we can use whatever log base that we want on these, and since we only have 2 log bases in our calculator, we can use common log, or you can use the natural log. Now I don't know which one you're going to feel more comfortable with, but it really doesn't matter. So I'm going to take this 5 to the x equals 90, and we're going to undo the exponent with a logarithm. So I'm going to use the common logarithm the first time. So the common logarithm of 5 to the x equals the common logarithm of 90. Remember your golden rule of equations. Whatever you do to one side, you must do to the other. Then we're going to use our power rule of exponents, or of logarithms. So it's x times common log of 5 equals the common log of 90. And that would mean x is equal to the common log of 90 divided by the common log of 5. So that should be our solution. I'm going to come back and do the calculation in a moment. We could also have gone this other route. Since we have both common log and natural log, you can use either log to help you undo exponents. So what I'm going to demonstrate here is that you can take the natural log of both sides and end up at the same conclusion. So we're still going to come back and use our power rule. So it's x times the natural log of 5 equals the natural log of 90. And that means x is equal to the natural log of 90 divided by the natural log of 5. As you can see, these two statements look very similar. The only difference is we have a different log base. And I just want to illustrate to you here that you can get the same answer whether you use a common log or if you use a natural log. So you can elect to do either one, common or natural. So if you take the common log of 90 divided by the common log of 5, your answer is, you can read that. Then if we come back and do the same calculation only using the natural log divided by the natural log of 5, we should be getting the exact same answer. So what I'm indicating to you is that you can go ahead and use either common log or natural log. It doesn't matter. We want to take your final answer and round it to the nearest 10,000th. So that is the 4th decimal place. So that means x is going to be approximately 2.7959. And that's what our goal is, to get to that final form for it. Okay, so then let's go ahead and grab this other one. I just put them both on the same video here. We're going to exercise the same idea. For whatever reason, I like natural logs. It's one less letter. We're going to solve for a variable that's in the exponent. So I'm going to take the natural log of 4 to the 3x minus 5 equals the natural log of 144. Then we're going to exercise our power rule. The log of the power is the power times the log. So it's 3x minus 5 times the natural log of 4 equals the natural log of 144. I want to undo multiplying by the natural log of 4, so I'm going to divide both sides by the natural log of 4, which means we have 3x minus 5 equals the natural log of 144 divided by the natural log of 4. Now you can go ahead and calculate and get that answer if you want, but I'd like to take care of the rest of this. I have to undo subtracting 5, so that means I'm going to add a 5 to this answer. So now I'm going to have 3x equals the natural log of 144 divided by the natural log of 4. Then I have to add 5. And then finally I got to take this whole answer and divide both of them by 3. So x is going to equal, I want to take this whole thing here that we just had, so the natural log of 144, natural log of 4, plus 5, and we want to take this and divide it by 3. Okay, so I'm going to go ahead and go through those steps. We're going to do the natural log of 144 divided by the natural log of 4. And I'm going to go ahead and get that answer. And then from there we want to subtract, or I'm sorry, add 5. And that answer we had to divide by 3. So divided by 3 equals, and our answer should be about 2.8617.